The motivation for why we have radian measure. I told you that the radian measure was considered like a real number measurement, and 1 radian was the size and angle had to be so that the radius of a circle and the arc length of the circle were equal. So it's more concrete than just saying a circle is 360 degrees. If you are going to do any calculations involving angles, they have to be in radian measure for these calculations to work out. So remember, this is what we were talking about at the very beginning when we defined a radian. The radian measure of an angle is your arc length divided by radius. So if you manipulate this formula and you want to solve for S, you could multiply by R on both sides. And so that gives us the formula for arc length, the distance on the outside of the circle. So that is the first formula on here. Arc length is S equals R theta if theta is in radians. So theta is your central angle, radius is R, the length of your arc is S equals R theta. But it only works if theta is in radians. So if I said your theta was 45 degrees, what would you have to do to that? Turn it into radians first. That's going to be true with any formula I give you. Okay, you have to convert it to radians. I am not going to make you memorize any formulas. So in this chapter, we're going to have several. I will give you a formula sheet on the test that has all of them listed. So you just have to know what those variables stand for. So you should recognize that S is your arc length, distance on the outside of the circle. R represents radius, and our theta is our angle in radians. So you have to know that part. So let's look at a problem. A circle has a radius of 25.60 centimeters. What variable do we use for that? R. So I know my R. Find the length of the arc intercepted by a central angle. So I'm looking for my arc. That means I'm looking for S in each of these scenarios. Today, we're really just using 2 formulas, so it's not a big deal. Later on, we will have more formulas. So I like to always write down what formula I'm using. Probably not especially helpful today, but it will be later on. Okay, so just a good habit to have. So S is equal to R theta. I know my radius, 25.60. My theta, 7 pi over 8. And so then I can just put this in the calculator. Your answer can be written different ways. So I am not real picky about how you write it. If you don't tack in the pi, you could write it as 22.4 pi. Or if you did that as a fraction, it's like 112 pi over 5. Or if you go ahead and multiply out the pi, it's 70.37. Okay, all of these are equivalent. I don't care. Most of the time I leave my answer in terms of pi, as long as it's not too ugly. But any of those are fine. Now I would like for you to put a unit on this. S is a distance on the outside of the circle. So what's my distance being measured in here? Centimeters, the same as the radius. So no matter which of those you pick, it's centimeters. If I look at B, what do you notice? It's in degrees. I cannot use my formula until it's in radians. So how do I convert 54 degrees into radians? Pi over 180. We need 180 on the bottom so that our degrees cancel. So then we just have, don't multiply out the pi here, just 54 over 180, which reduces to 3 pi over 10. So my radius is still 25.60 times 3 pi over 10. Bless you. So I get 7.68 pi centimeters. Or you could do a fraction, just like 92 pi over 25. Or if you multiply out your pi, 4 significant digits, 24.13 centimeters. All right, so you have to have one of those answers, not all three. In general, I'll probably leave my pi, like I'll probably write it as 7.68 pi, but you can do any of them. All right, is that okay? This question. Erie, Pennsylvania is approximately due north of Columbia, South Carolina. The latitude of Erie is 42 degrees north, while that of Columbia is 34 degrees north. Find the north-south distance between the two cities. And then I gave you the radius of the Earth. So we know the Earth is round, right? Does everyone agree with that? Nobody's going to argue with me there, hopefully. So I gave you two cities. Okay. And I gave you a latitude for each of those. What am I able to do with those two measurements? I gave you two different angles. I can use that to find my arc length. This is what I'm looking for, the distance between the cities. That's what I want to find. But I gave you the information to find the angle between them. Okay, if I gave you two latitudes, we can subtract those. We get 8 degrees. So that's the measure of this angle here. So I gave you the angle, and I gave you the radius. So we can find our arc length now. What should I do first? Yes, I cannot use the degrees in my formula, so I have to multiply it by pi over 180. This is my degrees, so what do we get? So now I can do the S equals R theta. My R is 6,400. My theta, 2 pi over 45. This one is pretty ugly if you type it in. The decimal is repeating. Fraction is not especially nice. Let's just go ahead and multiply out the pi. We're trying to find a distance anyway. So if I just multiplied out everything, what do we get?
893.6.
That would be in kilometers. R and S always have the same units. If I told you significant digits, let's refresh that. How many significant digits did I give you in the problem? 2. So if I rounded this to 2 significant digits, it would be 890. So never a bad idea to review those significant digits as we go through. Any questions there? Let's look at this one. A rope is being wound around a drum with a radius of 0.327 meters. So radius is R. I know my R. How much rope will be wound around the drum if the drum is rotated through an angle of 132.6 degrees? So angle is what variable? Theta. So I know my theta. Okay, I want to know how much rope. What variable am I looking for? S. The distance outside the circle, that's my S. What do you have to do first? Convert the degrees into radians. Why don't you guys see if you can finish this? Convert it into radians and then find your arc. So to change our angle into radians, you have to multiply by pi over 180. So those degrees cancel. So you have 132.6 over 180, which gives us 221 pi over 300. So then we can do our S equals R theta. R is 0.327. Theta, 221 pi over 300. So your final answer, you might have 0.24089 or 0.241 pi. If you multiplied out the pi, you get 0.757 if we wanted to do significant digits. What would my units be? Meters, the same as the radius. Arc length and radius will always have matching units. Yes?
So when you do like the pi over 180, how do you get that number?
So don't put in the pi. Just type in 132.6 divided by 180 and then do it math 1 so it's a fraction. Other questions? Did you get it to work?
Yeah, I was like making it so you could like type it in as a fraction and it was giving it this.
Oh, gotcha. All right, let's look at this one. Two gears are adjusted so that the smaller gear drives the larger one. What does that mean?
The small gears.
Yeah, we're spinning the small one, but they touch each other, so spinning that causes the bigger one to spin. The radii of the gears are 3.6 inches and 5.4 inches. All right, I'm going to organize this. I've got my small one, my large one. So for the small, the radius is 3.6. For the large, the radius is 5.4. The smaller gear rotates through 150 degrees. So my small angle is 150 degrees. Through how many degrees will the larger gear rotate? So what am I trying to find? The angle in the larger gear. All right, so if I'm looking at this, when these gears spin, okay, the small one spins, that causes the larger one to spin. What do these two gears have in common? What would be the same? What measurement's the same in both? They have a different radius. Is the angle the same? No. What is the same? What other variable have we been talking about?
The sector that's moving.
The arc length. If you think about the distance on the outside of the circle, they spin by touching each other, right? So the distance the first one spins has to be the same as the distance the second one does. I don't have that much information about my large gear right now, but could I find the arc length in my small gear? Yeah. First, I need to know my angle. So I can't do 150 degrees. What is that in radians?
5/6.
Okay, so now we can find our S. So if we do the S equals R theta, so if we do 3.6 times 5/6, I'm not going to multiply out the pi, we get 3 pi. So now I know my S. And the large one has to have the same s. So now what could we do? Find theta. We can do s equals r theta for the big gear. The s is 3 pi. The r is 5.4 times theta. So we divide the 5.4 over. Pi over 9. All right. Have I lost anybody? Am I done? What did the question ask me? Degrees. The number you put into the formula is radians. The number you get out is radians. So how do I convert this into degrees? 180 over pi. Pi's drop, and we get 100 degrees. That one was a little bit more involved, but still just using our same formula a couple times. Any questions there? I'm almost done. I want to talk about one more thing. All right. What if I want to find the area of a sector? So if that means, how do you find the area of a portion of a circle? To do that, you have to think about your actual area of a circle. We know for an entire circle, area is pi times the radius squared. So a sector is a portion of it. So we could think of it as a proportion. Okay, the area of a sector, so I don't know, is to the area of a circle. I know area of a circle is pi r squared. As the area of, as theta is to one full rotation. So if I'm looking for my angle, a full rotation, what angle is all the way around the circle? 360 degrees. So if I want to be in radians, 2 pi. All right, so I just set up a proportion. This is area of a sector to the whole circle, angle of the sector to the whole circle. So if I'm trying to find my area, you would multiply over the pi r squared. So the pi's cancel, and I get r squared theta over 2. Or another way that could be written is 1/2 r squared theta. That is the formula to find area of a sector, a portion of a circle. So on the next slide, I just restated that. That is another formula that would be given to you. I'm not asking you to memorize it, but I did want to show you where it came from. It's not just made up, it's related to the area of the entire circle. Just like any other formula, theta has to be in radians for this to work. So let's try a couple of those and then we are done. If I want the area of a sector of a circle that has a radius of 15.2 feet and a central angle of 108 degrees. So my angle is 108 degrees. What do I need to do? I have to convert, so take it times pi over 180. And if you do that, you get so Now I want the area of the shaded part, so the area formula is 1/2 r squared theta. 1/2. My radius is 15.2 squared. My theta is 3 pi over 5. So we can put this into our calculator. Just like anything else, you can choose to leave it in terms of pi, or you can multiply out the pi either way. So in terms of pi, it's like 69.312 pi. Or if you multiply it out, 217.75. What would my units be? Close. Area isn't just plain feet. Area is always square, so square feet. All right. Any questions there? I want you guys to try the last example for me. We have our lawn sprinkler. It's rotating 90 degrees and projecting water out 30 feet. So what is that 30 representing? Yeah. So our radius is 30. My angle is 90 degrees, which is what in radian form? We want the area of the lawn watered. So 1/2 r squared theta. 1/2 30 squared times pi over 2. So we get 225 pi, or if you multiply out the pi, 3 significant digits, it came out to be 706.858, so 707. What would my units be? All right, any issues? Then I have a handout for you, and we have just under 20 minutes to work on.